The last part of section 9.4 here is finding the sum of each infinite series. So again, we know how many pieces we have, but we don't know our first and our last. And in our formula, sum of a certain number of terms equals the number of terms divided by 2 times the sum of our first term and our last term. Okay, again, we know 40. But we don't know a sub 1 or a sub n yet. So we need to take our lower limit, plug it in, and our upper limit, and plug it in. And with those values, we will know our first and our last terms. So right now, I have the sum of the first 40 terms is 40 over 2. Our first term, we take 3 times 1 minus 8, negative 5. Our 40th term, I take 3 times 40 minus 8, 112. So the sum of our first 40 numbers is going to be 20 times 107, which is going to be 2140. For b here, if we look, this is not a linear function, which means we cannot use our sum formula. So we're going to have to find each value here. We're going to plug 1 in for n, and then we need to go all the way to 4. So I plug 2 in for n, 3 in for n, and 4 in for n. 1 cubed is 1, 2 cubed is 8, 27, 64. When I add all these up, I'm going to get 100. Okay. Last one here, again, is nonlinear. It's exponential. Our variable is in the exponent. So we're going to take negative 1 to the 0 power plus negative 1 to the first power. Okay. When we do that, we get 1 minus 1. Negative 1 to the 0 power is 1. Negative 1 to the first power is negative 1. 1 minus 1 is 0. So 0 to 1 is going to be 0. 2 to 3 is going to be 0. 4 and 5 are going to add to 0. So what we really need to look at here, guys, is every 2 are going to add up to 0. So we really just need to look at, since we're going to have n 101 times, remember 100 minus 0 plus 1 gives me 101. We really just need to look at what the last number is going to be. And our last term is going to be 100. So we take negative 1 to the 100th power, which is even. Whenever we take negative 1 to an even power, our answer is going to be 1, because our negatives, 2 negatives, make a positive. So we're going to have 100 negatives, and they're going to cancel into 50 positives, so we're going to end up with 1. Real quick recap here. When 2 terms and the number of terms in a finite arithmetic sequence are known, the sum of the terms can be found. And remember that a sequence can be defined explicitly by describing its nth term with the formula using n, or recursively by stating its first term and a formula for its nth term using the term before, the n minus 1 term. And there's your assignment for section 9.4.